Today we want to finish our conversation about solving quadratics by square root. If you'll recall from the video yesterday, all positive real numbers have two square roots. The positive square root, which we said was known as the principal square root, but also there is a negative square root. So for example, if we have the number 9, there are two different things that we could square to make 9. 3 squared makes 9, but negative 3 squared will also make 9. So we say that the square root of 9 is a positive and a negative 3. Okay. Remember, we show both of these roots by using the plus or minus symbol. And so, for example, we can say that our solution is plus or minus 3, plus or minus 1/2, plus or minus the square root of 7. Okay. All right, same steps as yesterday. In order to solve, we simply need to isolate our variable. What we should notice is different about these problems today is that our variable is inside of the parentheses. This x is locked inside of the parentheses because of the square on the outside. So we're going to isolate this squared term. We see that this is the only thing on this side of the equation. And so to undo or unlock that square, we need to come through and square root both sides. So if I square root here, I also have to square root on the right-hand side. The square root of x minus 1 squared leaves me with simply x minus 1. If you'll recall, the square root of 9 is a perfect square. The square root of 9 is 3. But remember that from now on, when we take a square root, we have to include that plus or minus symbol because both 3 and negative 3 can make 9 if they are squared. So at this point, we have x minus 1 equal to two different values on the right-hand side. So we're going to break this into two smaller linear problems. We can say that x minus 1 is equal to positive 3, but we can also say that x minus 1 is equal to negative 3. Solving on the left-hand side, we find that x is equal to 4. Solving on the right-hand side, we find that x is equal to negative 2. Remember that this is a quadratic because if I were to multiply x minus 1 times x minus 1, I would end up with an x squared term. So we have a quadratic, which means we have two solutions. One of our solutions is positive 4. Our other solution is negative 2. Okay. We can do a quick check real quick. So our original problem said x minus 1 squared was equal to 9. So if my x value was 4, this would say that 4 minus 1 squared should be equal to 9. Well, 4 minus 1 makes 3 squared, and we know that 3 squared does make 9. All right, if we check our second solution, negative 2 minus 1 squared should be 9. Inside of the parentheses, this gives me negative 3 squared, which is 9. And we know that negative 3 times negative 3 will make 9. So that solution checks. So we found the two values that x could be to make a true equation here. So two values that will allow me to subtract 1 and then square and get 9 as my answer. We have also found the x-intercepts for where the graph x minus 1 squared equals 9 will cross the x-axis. So that graph of that quadratic will cross the x-axis at both positive 4 and negative 2. All right, taking a look at our second example. Again, our job is to isolate the variable. My variable is located inside of a set of parentheses that are locked up by a square term on the outside. All right. That variable is isolated on this side right now, or the square term is. And so to undo that square so that we can unlock those parentheses, we're going to have to square root both sides. The square root of x plus 3 squared is just x plus 3. And then the number 49 is a perfect square, so we can just take that. The square root of 49 is 7, but remember, we now have to include a plus or minus with our 7 because both positive 7 squared and negative 7 squared will make 49. At this point, our equation, we are equal to two different values on this side. So we're going to split this into two smaller linear equations. One is going to say that x plus 3 is equal to positive 7, while the other one is going to say that x plus 3 is equal to negative 7. Solving here, we're going to subtract 3 to get that x is equal to 4. And subtracting here, we're going to get that x is equal to negative 10. We have found the two solutions that will make the equation true. We also know that these are the two places that this parabola will cross the x-axis, when x is 4, and again, when x is negative 10. And then just a quick check, 4 plus 3 does make 7. 7 squared is 49. Here, negative 10 plus 3 will give us negative 7. Negative 7 squared will also make 49. In example number 3, our x, again, is located inside the parentheses with the square on the outside. The problem is that square term is not isolated, so I cannot square root yet. I have to get rid of this 3 before I can come through and square root this side. 3 is multiplying the x minus 5 squared, so we are going to undo that by dividing. So divide both sides by 3. These cancel to leave me with x minus 5 squared. And on the right-hand side, 12 divided by 3 leaves us with 4. Now that our parentheses with the square is isolated, right, we can unlock those parentheses by taking the square root of both sides. I can undo a square with a square root. This is going to leave me with x minus 5 on the left-hand side because the square root and the square cancel each other out. And on the right-hand side, the number 4 is a perfect square, so we are simply going to take the square root, making sure to include our plus or minus symbol. At this point, we have an expression here on the left-hand side equal to two things here on the right-hand side. So we're going to split this into two smaller problems. X minus 5 is equal to positive 2, but x minus 5 here on the left is also equal to negative 2. Okay. Solving here, we get x is 7. Solving here, we get x is equal to 3. Right? So that means we have found the two solutions that will make this equation true, if x is 7 or if x is 3. And again, we can do a quick check. 7 take away 5 is 2. Order of operations says we're going to square that to get 4. 3 times 4 makes 12. When I check the 3 take away 5, so doing parentheses first makes negative 2. The next step in order of operations is to square. Negative 2 squared means negative 2 times negative 2, which makes 4. 3 times 4 will make 12. All right, in question number 4, we need to isolate that parenthesis because that's where our variable is. So we need to get rid of that 5. I cannot come through and square root until the squared term is by itself. And in this case, the entire parentheses is being squared, so we need to get it by itself. So we're going to come through and we're going to add 5 on both sides to get that x minus 1 squared is equal to 25. Right. Trying to get x by itself, I see it is located inside a set of parentheses with a square on the outside. So to undo the square, we're going to come through and square root. That's how we undo a square, square root. On the left-hand side, that leaves us with x minus 1. And on the right-hand side, 25 is a perfect square. So we'll simply take the square root, making sure to include our plus or minus symbol. The left-hand side is going to become x minus 1 equals positive 5, but we also get that x minus 1 is equal to negative 5. Adding 1 on this one gives me that x is 6. Adding 1 on this one gives me that x is equal to negative 4. So we have two solutions here. One is 6 and one is negative 4. Those are the only two numbers that will both make this equation true. Also, these are the two places the line crosses the x-axis. A real quick mental check, 6 take away 1 makes 5. Squaring that, I get 25 minus 5 is 20. Negative 4 take away 1 makes negative 5. Squaring that, I get 25 minus 5 is 20. Okay, continuing on. Number 5, I see my variable is located inside of the parentheses. All right, those parentheses have a square that is locking them up. So to undo this, I'm going to square root both sides. The square root of t minus 4 squared is t minus 4. But this time, the number under the radical, or my radicand, is not a perfect square. 7 is not a perfect square. So we can try to simplify the square root of 7. If I think about coming out here like we did yesterday and trying to simplify 7 into its prime factors, well, 7 is prime. All right. So there's no way I can simplify the square root of 7 because I'm not going to have any pairs of numbers. So we're going to have to leave this as the square root of 7, making sure that we put the plus or minus in front. At this point, we want to solve for t. So we're going to write our two equations. T minus 4 is equal to the positive square root of 7, but t minus 4 is also equal to the negative square root of 7. Adding 4 here. Adding with radicals is very similar to adding like terms. I can only add if the radicands match. I have a radicand here of 7, but 4 does not have a radicand of 7. So I cannot actually add these and make them something like square root of 11 because one of them has a radical and one of them does not. So the best thing I can do is write the whole number part and then write the radical. So I have a positive 4 and I have a positive square root of 7. Adding 4 over here, again, I cannot combine something that has a radical with something that does not. So t is equal to, again, we typically write the whole number part first, followed by the radical. So this was a minus or negative square root of 7. So we do, in fact, have two solutions here. One of our solutions is 4 plus the square root of 7, and one of our solutions is 4 minus the square root of 7. In our second example of number 6, again, we have our variable. It is located inside of a set of parentheses that are being squared. So to undo the square, we're going to come through and square root both sides. Right? On the left-hand side, x plus 6 squared just becomes x plus 6. But on the right-hand side, 48 is not a perfect square. So we can't just take the square root. But we should come out to the side of our paper and see if we can reduce the square root of 48. Okay, so can we rewrite it so that it is simplified? So thinking about things that multiply to be 48, 2 times 24, we'll break that down into 2 times 12, 2 times 6, and 2 times 3. So the square root of 48 is the same thing as 2 times 2 times 2 times 2 times 3. I have a group of 2's here and a group of 2's there. So 2 times 2 is 4, but we're taking the square root of that, so that's a 2. Here, 2 times 2 is 4, but we're taking the square root of that, so that is also a 2. And then here, we do not have a partner to go with that 3, so we're going to leave it. So it looks like 48 can be reduced to 4 square roots of 3. When we write that down, we want to make sure that we include that plus or minus symbol. So square root of 48 is the same as plus or minus 4 square roots of 3. All right, remember that we have something on the left equal to two different things on the right, a positive 4 square roots of 3, but also a negative 4 square roots of 3. So we're going to write our two smaller equations. X plus 6 equals positive 4 square roots of 3, but x plus 6 is also equal to negative 4 square roots of 3. On the left-hand side, we need to subtract 6 on both sides. So x is equal to, Remember that we cannot combine these things because this term has a radical and this one does not. We typically write the whole number part first, followed by the radical. So we have a -6 and a positive 4 square roots of 3 here. On the right-hand side, we're going to subtract 6. So x is equal to, and again, cannot combine these things because one of them has a radical and one of them does not. But what we can do is write the whole number part and then know that in this case we have a minus or are subtracting 4 square roots of 3. So we do have two solutions here. One of them is -6 plus 4 square roots of 3. The other is -6 minus 4 square roots of 3. Our last two problems. On number 7, I can see that my variable is located inside a set of parentheses that is being squared. That set of parentheses is isolated on the left-hand side. So we're going to come through and we are going to square root both sides in order to undo that square. On the left-hand side, we are left with 2x minus 1 because the square root of 2x minus 1 squared is just 2x minus 1. On the right-hand side, go ahead and write down your plus or minus. And then we need to think about if we can simplify the square root of 24. So if I bring 24 out, I get 2 times 12, 2 times 6, 2 times 3. So the square root of 24 is 2 times 2 times 2 times 3. All right, I've got a pair of 2's here, but I don't have pairs for either of these, right? So 2 times 2 is 4, but we're taking the square root of that. So the square root of 4 is 2. And then underneath the radical, these don't have pairs. Also, 2 times 3 is 6, which is not a perfect square, so we're going to leave the 6 inside. So this becomes plus or minus 2 square roots of 6. Okay. Now we're going to write our two equations because we have this on the left equal to two different things on the right. So 2x minus 1 is going to be equal to the positive 2 square roots of 6, but 2x minus 1 is also going to be equal to negative 2 square roots of 6. Right. On the left-hand side, we're going to add 1 to both sides. Right. So the left-hand side is 2x, and on the right-hand side, I cannot combine 1 and 2 square roots of 2 because they are not quote-like terms. So I'm going to write the whole number followed by the radical. And then finally, to solve for x, we're going to divide both sides by 2. So it looks super messy, but our solution here is 1 plus 2 square roots of 2 over 2. On the right-hand side, we're going to do the same steps. We're going to add 1. So 2x is equal to 1 minus 2 square roots of 6. And when we divide both sides by 2, we get that x is equal to 1 minus 2 square roots of 6 over 2. Thinking about our two solutions there, one of our solutions is 1 plus 2 square roots of, my bad guys, these should all be 6's. My apologies. So 1 plus 2 square roots of 6 over 2 and 1 minus 2 square roots of 6 over 2. All right, for our final example, again, we see our variable is located inside a set of parentheses that are being squared, but those parentheses are not isolated on this side because we have a 2 here multiplying them and a 3 subtracting them. Very similar to what we did yesterday, if I had 2x minus 3 equals 15, and I think about how I would solve that, I would add 3 to both sides so that 2x equals 18. And when I divide by 2, I would get something like x equals 9. We're going to isolate our squared term the exact same way we would isolate this x. Okay. So looking back over here, first thing we would want to do is to add the 3 on both sides. So 2 times x plus 1 squared is equal to 18. Continuing to isolate the parentheses, we're going to divide both sides by 2. So x plus 1 squared is equal to 9. All right, at this point, that variable is located inside the parentheses that are being squared. It is the only thing on that side, so we are now able to come through and take the square root of both sides. The square root of x plus 1 squared is simply x plus 1. And because 9 is a perfect square, we can say that the square root of 9 is plus or minus 3. Okay, that plus or minus is key. All right, we've got something equal to two different things on the right, so we write these as two smaller problems. X plus 1 equals positive 3, but x plus 1 also equals negative 3. Subtracting 1 here, x is equal to 2, and subtracting 1 here, x is equal to negative 4. So we have found our two solutions to be positive 2 and negative 4.